In this section, we will see competition corner. What are the factors that affects the rate of chemical reactions? What is the meaning of rate of chemical reaction? Rate of chemical reaction means change in concentration of reactants and product per unit time. Change in concentration of reactant or product per unit time means in unit time how much is the concentration of reactant and product has been changed. So in equation form we can write like this thing. Change in concentration means reactant product amount of concentration and what is the time taken in which this concentration is changing into product forms. So we will see next how the other factors which affect this rate of chemical reactions. So one important factor is concentration of the reactant. If the concentration of a reactant is more, then rate of reactions will be changing. How it is changing? So you say calcium carbonate is the one substance. So it is called limestone. So on heating, if you will get calcium oxide plus carbon dioxide. So if you increase the carbonate more and more reactants or giving heating continuously, so you will get this product on one side as a product continuously. Same temperature. So temperature also affects the rate of chemical reactions. So we have one example, gypsum. Formula of gypsum, calcium trisulfate. So if you heat gypsum at 100 degrees centigrade, it will convert into plaster of Paris. Plaster of Paris, calcium sulfate, half H2O. So it is the one of the substance in which used by the doctor to just setting the during the fracture time. So it is used in during setting the. It is converted when doctor put plaster of Paris after addition of water in this, so it is converted into gypsum. Okay, so it has some setting property. It takes place at 100 degrees centigrade. It is used for making statues also. But same plaster of Paris, if you heat increase temperature more than 100 centigrade, it will convert into calcium sulfate. So and it will lose water of crystallization. This is water present in the calcium sulfate as a crystal. So this calcium sulfate do not have a setting property. It is called as a anhydrous calcium sulfate or dead bond plaster. So there is a more temperature. It is more than 100 degrees centigrade. It is more than 100 degrees centigrade. Now if you heat the same gypsum at less than 100 centigrade, what will happen? So what will happen? The formula will remain same of gypsum. So it will convert into another different type of crystals, but formula will remain same. So in this way, temperature you can say every reactions it plays a very important role. Next, surface area of the solid reactant. So if the reactant is solid, so their surface area also it depends. So we have to break the solids into small pieces. So small microparticles of the solid have a more surface area, then reaction will take place more fastly and smoothly. For example, for hydrogenation of oil, what happens? We do finely hydrogen powder and passing hydrogen on over the nickel powder. So on this hydrogen on the oil, and this hydrogen will added with the oil via nickel powders. If the surface of the is micro in powdered form, then possible. If you take the solid forms big in a large size, then reaction will not occur. But if you take powdered form, the surface area of that powder becomes more and more larger. Nature of reactant. Nature of reactant means nature of bonding between the reactant molecules. So here ionic compounds react faster than the covalent compounds. So ionic compounds can be here. Nature bonding is this one. Ionic bonds is there. So during solution states, what happens? These bonds break easily and reaction become faster. But here covalent bonds, they have a stable bonds are there. So to break these bonds, again it requires more time. Okay, so here again nature of reactant also plays. Nature of bonding also plays in the reaction of chemical reaction by the reactant. Nature of solvent. So nature of solvent, it dissolves the reactant. Nature of solvent means solvent dissolves the reactant. So on reaction, what happens? The reactive species will get more surface area after breaking the bond. So if there is more surface area, then there will be more reaction. So solvent also plays in chemical reaction, rate of chemical reaction. Next is your intensity of light. So if there will be more light, if there will be more intensity of light, means more number of photons in light, then what will they will excite the number of molecules, and chemical rate of chemical reaction will go very faster. We have seen in photochemical reactions in previous examples. pressures. So pressures, again, it is application applied for the concentration of the gases, amount of concentration of the gases. Means in gases, if the number of molecules increases, means their partial pressure of the gas on heating, each molecules will heat on one another. So there are so many molecules are there. So if you increase pressures, what happens? If you increase pressures, what happens? These molecules will collide each other. So number of collision increases, means more reactions increases, rate of reaction increases. Catalyst. What is catalyst? Catalyst is actually, it is a substance which alters the chemical reaction without changing itself. So catalyst is not involved in the chemical reactions, but it increases the speed of the rate of chemical reaction. So we have examples like in human beings we have seen digestions. There are so many enzymes are there. So these enzymes are help in converting the nutrient into the small pieces, like pepsin is there. Okay, so in our this one, in chemical reaction also we have examples like if you take H2O2, so it will convert into hydrogen plus H2O plus oxygen. So we require here HBr as a catalyst. Okay, so what happens? They will convert this hydrogen peroxide into water plus oxygen. Without this is not difficult. It's difficult. So here we require one catalyst for reaction which speed up the reaction, which fast the reaction. Reaction can become slow, reaction can be fast. So catalyst has a very major role in playing the rate of chemical reaction. Actually, what is the role of catalyst? So catalyst, actually they decrease the activation energy. Activation energy we discussed in previously, that it is nothing but the minimum amount of energy to convert the reactant into that time where a bond can be easily broken or bond can be easily formed. So in previous, if you see, if you remember the previous energy profile chart, I have drawn some chart of the exothermic reaction, endothermic reaction. So this is the reactant and this is the product. This is the energy profile, this is the potential energy of the reactant, and this is the rate of the reaction. So this is the example of exothermic reactions, and we can see here this is called as the activated complex, where the bond formation of bond and formation of bond breaking and breaking take place here. So this is going on uncatalyzed reaction, and from here this energy to this energy is called activation energy. So what is the role of catalyst? Catalyst will decrease this energy to this level. Okay, this level is decreased by the catalyst. So this is called uncatalyzed reaction and this is called catalyzed reaction. So in this reaction, what happens? If the reactant will go up to here, so it will take less time and immediately product will be formed. So here there is no participation of the reactions. Okay. Orientation of the reactant space. Orientation means during the collision of the molecules, reactant molecules, what happens? So what happens if the orientation of the molecules, orientation means orientation of the molecules will be proper manner, then there will be greater rate of reaction. So I have taken this iodine is reacting with the ROH. ROH means is a kind of alcohol. So if the alcohol molecules is ROH, this is one orientation. This orientation means this iodine is just behind the R, and if it is striking, it is colliding with R molecules, then what will happen? The reaction will take place, IR, and this O will come out. This O will come out. So this is called proper orientation. Okay, where number of collisions properly collide with each themselves and reaction take place. But if you take ROH and plus iodine, so here iodine is just behind the OH. Okay, so what will happen? Reaction will not take place. So orientation of the reactant spaces with proper directions, proper space in the space is must. Only collision here, only collisions here, only collisions occur, no reaction. But here proper reaction will occurs. So thank you.